dear friends, this is Dr. Diptesh Patel and I will be teaching you Advanced Internal Combustion Engine. In today's session, we are going to go through the gas exchange processes in which we are going to cover the fuel injection system and the scavenging process, which is been widely used for the different purposes in IC engine. So let's start with the fuel injection system. But before we begin the fuel injection system, because we use the several types of the fuel injection system for both petrol and diesel engine, let's understand how does the inlet and exhaust processes takes place. So normally the inlet system is having the different components such as air filter, carburetors, or even the modern multi-point fuel injection system and throttle, or even the fuel injectors. Similarly, the exhaust system is also consists of the various components such as exhaust manifold, exhaust pipes, and catalytic converter. So basically, there are a number of different components which is been kept into the both inlet and exhaust line. These components are also reasons to reduce the pressures of the incoming air or the outgoing gases into the both main lines, and they may also create a lot of problems. We have also need to understand how we can reduce the pressure drop or pressure losses problems in both inlet and exhaust pipes. Even there are a lot of different research topics that can be carried out as a master degree students or even a PhD topic which are relevant to the both inlet and exhaust line regarding the pressure drop. So here we are going to go through the few fuel injection system, and one of them is a pot injection system. So you can see in pot injection system, which is like in which the air is only supplied into the intake manifold while the fuel is injected into the individual pot. So basically the certain quantity, even let's say the same quantity, depends on the what type of the requirement it is, the same quantity of the fuels is injected into the each individual pot, whether it could be the 6 cylinder 6 pot or 8 or 12 or even 2. So in pot injection system, fuel is directly injected into the pot instead of mixing it together into the carburetor and then supplying it into the intake manifold. The other one is a throttle injection system. In throttle injection system, fuel is injected into the body, throttle body, and where air and fuels are combined, they mix together into the throttle body, and then after it would be supplied into the each intake manifold through the inlet valve into the cylinder, and that quantity would be depends on the requirement of the engine, and they are pretty much similar. So in throttle injection system, the fuel is injected into the throttle body. Now the latest fuel injection system which is been widely used into the engine is a multi-point fuel injection system. It is used in SI engine. Here the multi-point fuel injection system is completely electrically controlled, and in which we use the electronic controlled unit, which is known as the ECU. Now ECU works on the data input of the various sensors, such as it has the cooling water temperature sensor, it has the engine speed sensor, then the exhaust gas temperature sensor, or even the amount of oxygen that would remain into the exhaust gas, that can also be sensed. Then it has the air volume sensor and the air temperature, inlet air temperature sensor as well. So it has a number of sensors, approximately 6 to 7 different sensors are used. They are kept into the engine, such as the inlet air temperature sensor and air volume sensor is kept in inlet manifold. Then engine speed sensor is kept into the camshaft. Then we have the cooling water temperature sensor that would be remain into the outlet of the water jacket, and the oxygens amount of oxygen in exhaust gas sensor is kept at the exhaust manifold. So this sensor would provide the informations to the ECU, and based on that information, ECU supplies the informations to the fuel injector to supply the amount of fuels which is required for the particular applications to be run for the engine. So basically this is the very precise uh, fuel injection system as compared to the previous one, such as the carburetor and different types of the carburetor in fact, that would provide the more precise informations, and that it would optimize the consumptions of the fuels, enhance the overall efficiency of the engine. Now let's move forward to the next topic here, that is the scavenging system. Now scavenging is basically the process of removal of the exhaust gases from the engine cylinders. Now we have understood in the first session that we have the four different strokes, such as suction, compressions, power, and the exhaust strokes. So basically in exhaust strokes, when all the gases that has been burned out and that energy has been utilized, they need to remove from this engine cylinder to have to get the maximum optimized work. Because these space is occupied by the gases, if these gases would be cleared out 100% from the cylinder, then we can get more fresh charges for the next cycle. So to optimize the overall performance, we need to remove all the gases from the engine cylinder through the exhaust system. So this removal process of these gases from the cylinder is known as the scavenging process. Now why it is important to have this scavenging process, why it is necessary? So since we know that there are few gases, right, few incomplete combustion gases, right, they would be dilute with the fresh charges if they are not completely removed from the engine cylinder, and if they dilute with the fresh charges, fresh air and fuel mixture, then the overall power would be reduced, and even the emissions, the pollutions which is coming out from the engine cylinder would also be an increase. So therefore these incomplete combustible combustion gases that need to be get out from the cylinder. Then in scavenging process, if the scavenging process is not complete, cannot be completed properly, then there may be a chances to lose the fresh charges along with the gases through the exhaust post, and this especially happens in two stroke engine, right, because like for certain period of time both valves are remain open, both the transport port and the exhaust port, they both remain open for this shorter period of time, and there may be a chances that all the fresh charges which is coming in from the transport port, they may leave through the exhaust port. So these there is a chances of losses of the fresh charges as well, and because of these losses of the fresh charges and because of the dilutions, the overall thermal efficiency can also be reduced if we do not have the proper scavenging system. So these are the reasons why we required the proper scavenging system. Now how could you achieve the scavenging system? Now scavenging system can be achieved with the different arrangement, and the most common arrangement which is specially used in two stroke engine is a crankcase scavenging. Since the inlet port supply the fresh air and fuel mixture, or maybe air if it is a diesel engine, then it would occupy the space below the or underneath of the piston, which is known as the crankcase. Now these fresh charge would remain into the crankcase, and when the transport port is remain open, this fresh charge forcefully with a certain amount of pressure entered into the cylinder, and they would push the exhaust gases, to get out through the exhaust valve, and this is how the scavenging can be achieved by the help of the crankcase. So that one is a simple method, and which is mostly used for the like single cylinder small engine for the agriculture purpose, or even for the small scooters. But if we have like the higher range of the engine, two stroke engine, then we required a certain types of the scavenging process in which we can properly allow these gases to be removed from these cylinders, and one of them is a cross scavenging. So you can see over here, in cross scavenging, we have the inlet valve and exhaust valve, they would remain into the opposite end, and the fresh charge which is coming in from the inlet valve, they would enter into the cylinder. At the same time, the exhaust port would also be remain open, so the fresh charge would push the exhaust gases which are into the cylinder, and these gases would get out through the exhaust port. Also, you can see the deflector here. This deflector is provided to reduce the fresh charge losses, because there may be a chances that all the fresh charges which is coming in from the inlet valve, they may lose or they may get out along with the exhaust gases through the exhaust port. So therefore, the slight angle, the reflector is provided, which would reduce the chances of the losses of the fresh charge through the cylinder along with the exhaust gases. So this is the cross scavenging process. Then the second one is a loop scavenging process. Now loop scavenging process can also be further classified in various categories, such as MAN type, then Scannell type, or the Curtis type. So it has the like different sub classifications of the loop scavenging process, in which we are going to see one by one. The first one is a MAN type, in which both inlet and exhaust port are remain at same side, but the inlet port would remain at the lower side, while at the lower stage, and the exhaust would be remain at the upper stage. So while piston moving from the top dead center to bottom dead center, first of all the exhaust gases would open, and that because of that the fresh charges would start to leave the cylinder. When it further come down, when the piston further come down toward the bottom dead center, the inlet valve open. So like since the exhaust valve open first, the few gases would already started to leave the cylinder, and when the inlet valve open, this would allow the fresh charges to be enter into the cylinder, and that would further push the gases to leave the uh, exhaust valve. Mm, and then after, when the piston move from bottom dead center to top dead center, first of all the inlet valve close, and then afterward the exhaust valve closes. So in that kind of system, there is a less chances of the losses of fresh charges. The second one is a Scannell type. In Scannell type, we have the inlet through the center and exhaust through the one side. So basically, when these inlet fresh charges would enter through the center, that would go into the cylinder. There are a slight of angle of attack, or even the deflections of the inlet of these gases has provided, so to reduce the losses of the fresh charges, and these fresh charge would push the exhaust gases to leave through the exhaust valve. While the third one is a Curtis type. In Curtis type, we have the inlet through the uh, one side, while the exhaust at the other side. And basically, in here we have the different types of the swirlings and tumbles takes place inside the engine cylinders, and the Curtis one is the most efficient scavenging process as compared to the others ones, in which the like different types of the fresh charges would be allowed to leave from the three different sides, like all the three different sides would provide the inlet. So the fresh charges would enter from the like almost half of the cylinder, while the remaining would goes out from the remaining one. So it has more number of ports as compared to the MAN type or Scannell types, and therefore the removal of these exhaust gases would be more efficient as compared to the other ones. So yeah, these were all these different types of these scavenging processes that we have seen. We have even few more as well, these scavenging processes, and like the overall aim of all the engineers is to remove all the gases which are not useful at all, because they occupy the space, they dilute the fresh charges, and they overall reduce the thermal efficiency of the engine. So therefore it is very important to take out all the gases as much as possible to enhance the overall efficiency of the engine. All right, so this is all in this session. If you have any doubt, you can write down in the comment box. Thank you very much for attending the session. Thank you.